Hi guys, Sajjad Hussain again with a new video. In this video I am going to check the design of a doubly reinforced beam given in this PCA handbook of ACI 31808 with SAP2000. The problem is something like this. A beam cross section is limited to the size shown. Determine the required area of reinforcement for service load moments. Dead load moment is 430 kip feet and the live load moment is 175 kip feet. Check crack control limits of 10.6. Okay. Now here is the figure given. The beam width is 12 inch. The top reinforcement or the compression reinforcement are as a depth of 2.5 inch. Effective depth of the bottom bars, they are 30 inch. So if we add 2.5 to the 30, that means overall depth will be approximately 32.5 inch. And the loads are given. So let's model this beam and let's see the result. We will start with new model in SAP2000. The units are kip and feet. Let us assume what we will do, that we will convert these moments into loads and we will apply the loads. Let us assume that the beam has a length of 10 feet. So let us start with unit kip feet and let's have this grids only. So in X direction there will be 2 grids. In Y direction there will be only 1 grid. In Z direction there will be only 1 grid. Spacing in X direction is 10 feet. And in Y and Z is the material. Let's see. 10 feet. Okay. Okay. So we are not interested in this 3D shape. So here is the figure showing the grids. We don't want to see this axis, so let us put this axis off. Now we have to define material. 4000 psi concrete, that's okay. And let us add the bars. Rebar is 60 ksi, ASTM A615, okay. So rebars are added. Let us define the frame section. Now frame section here we will import concrete frame section, rectangular. We will add new property, concrete, rectangular. Let us name this section as beam. Now we know that the overall depth was 32.5 inch. Here the depth is 1.5 feet because our unit is feet. So shift, double click, the calculator is here. We want to convert this feet into kip. So here unit is kip inch. 32.5. It should be converted into kfit. So the result is 2.71 or 7083. Okay, and here 12 inch means 1 feet. So depth is 32.5 inches or 2.708 feet, and width is 1 feet. Our concrete is 4000 psi. Let's see the section properties. These are okay, calculated. Reinforcement, longitudinal bar, okay, 60 ksi, and this should be treated as a beam, and let it be by default leave it as default. So here it is. Okay. Now we have to define the load pattern, only one, and since we are defining the dead load and live load, so no need to have a multiplier 1 over here. We will say this multiplier will be 0. Okay, now let's define the load cases. We are not interested in modal analysis, so let us delete this load case. Now let us define the beam. Here is the beam, so it will start from here and it will end up to here. Okay, now we have to assign support conditions. Let us assign restraint conditions. Let us say here it is pin connection, and on this side let it be a roller. Okay, now we have to assign load. To convert this, let us convert this into a point load. So we know that the very simple formula for a simply supported beam having a single point load is WL by 4. So if I convert this 430 kFit moment into a point load, this comes out to be 172 kips. Very simple calculation. So let us assign this load over here. Assign frame load, point load. First is dead load, and this will be acting in the middle. No need to have these. Let me 0 0, and then this is 172 kip. Okay, and let's replace this with the existing. There is no existing, so this is the load we are applying over here. So here is the dead load applied. Now similarly we can apply live load. Okay, so let's assign frame load, point load. Let us sorry, we have not defined here the live load, so let us define the in load pattern. Let us define the live load also. This is our live load. Add a new load pattern. Okay, so load cases are dead and live. Fine. Now we have to assign a point load for live load case. In this case it's not 172, this comes out to be 70 kips. If we convert 175 kif moment into force, so this will be 70 kips. So let's replace this, apply. Okay, now we have to define a load combination. Load combination is 1.2 times dead load plus 1.6 times live load. So let us define a load combination, new combination. Dead load is 1.2, add, and live load is 1.6, add. Okay, now let us save this file. This is example 7.3. Let us save this file. So this is example 7.3. Now we can analyze, run analysis. Okay, set analysis option. Okay, let it be like this. We are not interested in grids anymore. Let us delete the result. Okay, now our analysis option is a plane frame. Let us analyze. So now we can check the bending moment, that we are calculating the correct bending moment for both dead load and live load cases. Let us display. For dead load bending moment, we can see the value. So here is 430, absolutely correct. Similarly, we can display live load. Live load comes out to be 175. So live load moment is 175 feet, absolutely correct. Now let us see the combined result moment. So let's see the combined one. $796. So absolutely perfect result we are getting from SAP 2000. Now let us design and see whether we are getting the same result or there is some difference. Here it is calculated as compression steel as 0.79 and the tension steel is 7.29. They have used a technique, so not necessarily we SAP follow the same technique, but let's see. Let's design concrete design. Let us see the preferences. Design code is 31811. Loads okay. Number of iteration okay. Seismic design category D, no, we will go for a simple case. Seismic design category as A. Rho and STS we are not interested now. These parameters are okay, so this is fine. select design combo. Let us select this combination. Start design. So the result is there. This beam falls in a gray area, that means this beam is safe. Let us check. Verify analysis versus design. Analysis and design section match for all concrete frames, that is correct. Design, concrete frame, view all member passed. Yes, the member qualifies, the member passes the check. Fine. So what's the result now? The summary, it shows that top reinforcement should be 0.003 feet square. Let us change into inch. So the top bars are 0.498, almost 0.5 square inch, and the bottom bar is 6.972, that means almost 7 square inch. And here the values are little bit different, 7.29 and 0.79, little bit higher side. So that means the results are also conforming, and we will select the same bar size, although there is slight difference here, but we are satisfied with the result. So this shows that the SAP results are perfectly in line with the manual calculations. So thank you very much for watching this video. Hopefully you will like it, and in future more videos I will be bringing. Thanks a lot. Bye.